Student, welcome back to your favorite technical channel AVM Tech Android. Today we are going to discuss about chapter 2 of basic mechanical engineering, that is property of steam. In this chapter we are discussing topic number 3, that is a throttling calorimeter. So what is the purpose to use the throttling calorimeter? So in the previous video we had discussed about working of separating calorimeter. Now we are discussing throttling calorimeter. So throttling calorimeter is used to find out the dryness fraction of the steam. So what is the X value of the steam which is flowing through the system, we can find out that. So it works on the throttling process, and that is a isenthalpic process, or it is called enthalpy remains same, or it is also known as a constant enthalpy process, meaning enthalpy remain constant during the throttling process. So enthalpy before throttling and enthalpy after throttling remains same, that is a isenthalpic process. So if we'll talk about the principle of working of the calorimeter, what you will observe here is it is a isenthalpic process. So H1 equals to H2, that is enthalpy before throttling, and enthalpy after throttling remains same. So यहाँ पे क्या होगा दोस्तों कि जो स्टीम एंटर होगी उसका टेम्परेचर तो कांस्टेंट ही है, बट व्हाट यू विल ऑब्जर्व इज कि when wet steam is passed through the throttle valve or throttle device or a small orifice, its pressure will drop suddenly. That will expand and it becomes superheated. So what you can see here is a steam table. This is a pressure based steam table. What I told to you is at 1 bar pressure, what you can see here is the saturation temperature is 99.62. Okay, so when the question is asked to you कि भाई water का boiling point temperature क्या है, तो that is 100 degree Celsius, but that is at 1 bar pressure. If the pressure is, you can say, 0.5 bar, the saturation temperature is 81.33. ओके, सो जैसे जैसे प्रेशर चेंज होता है, सपोज ये 0.5 प्रेशर है, तो आपका सेचुरेशन टेम्परेचर और बॉइलिंग पॉइंट टेम्परेचर चेंज हो जाता है. सो अभी आप ऐसा समझे कि स्टीम एक बार प्रेशर पे आ रही थी. सो बिफोर थ्रोटलिंग प्रेशर इज 1 बार, सेचुरेशन टेम्परेचर इज 100 डिग्री सेल्सियस. बट जैसे ही वो थ्रोटल हुई उसका प्रेशर ड्रॉप हो गया. प्रेशर ड्रॉप हो गया तो क्या हुआ कि उसका प्रेशर 1 बार से 0.5 बार हो गया. उसका प्रेशर ड्रॉप हो गया तो कॉरस्पॉन्डिंग टू 0.5 बार प्रेशर व्हाट इज सैचुरेशन टेम्परेचर 81. बट आपकी स्टीम कितने टेम्परेचर पर है, 100 पे. मतलब कि 81 पे होती तो सैचुरेटेड स्टीम थी, अभी 100 है तो इट इज़ अ सुपर हीटेड स्टीम. So it is not like a magic your steam is converted into superheated steam. This magic is because of drop in the pressure. So when the pressure will drop, its boiling point temperature will drop. And when the boiling point temperature will drop, the steam at same temperature is considered to be a superheated steam. So again I am telling in Gujarati કે ભાઈ સ્ટીમ તો 100 ડિગ્રી ટેમ્પરેચર પર આવે છે, ધારો કે એક બાર પ્રેશર है, તો એ વખતે એનું બોઇલિંગ પોઈન્ટ ટેમ્પરેચર 99 છે, બરાબર. હવે જેવું થ્રોટલ થશે એટલે શું થશે, એકદમ એનું પ્રેશર ડ્રોપ થશે. હવે સ્ટીમ તો 100 ડિગ્રી ટેમ્પરેચર પર આવી જ ગઈ છે અંદર, પણ હવે એકદમ પ્રેશર ડ્રોપ થયું એટલે શું થયું, ધારો કે 0.5 બાર પ્રેશરે આવી ગઈ હતી, તો એ વખતે 0.5 બાર પ્રેશરે એનું બોઇલિંગ પોઈન્ટ ટેમ્પરેચર કે સેચ્યુરેશન ટેમ્પરેચર કેટલું છે, 81.53. બરાબર. સ્ટીમ જ્યારે 0.5 બાર પ્રેશર પર હોય ત્યારે 81 ડિગ્રી ટેમ્પરેચરે આપણે એને સેચ્યુરેટેડ સ્ટીમ કહીએ. અને અત્યારે આપણી સ્ટીમ કેટલા ડિગ્રી પર છે? 100 ડિગ્રી પર. એટલે આપણી સ્ટીમ છે જે અત્યારે આફ્ટર થ્રોટલિંગ એ સેચ્યુરેશન ટેમ્પરેચર કરતાં ઉપરના ટેમ્પરેચર પર છે. મીન્સ ટેમ્પરરીલી આપણી સ્ટીમ સુપર હીટેડ સ્ટીમમાં કન્વર્ટ થઈ ગઈ. કેમ કે પ્રેશર ડ્રોપ થઈ ગયું. ઇનિશિયલી પ્રેશર 1 બાર હતું, હવે પ્રેશર કેટલું થઈ ગયું? 0.5 બાર. એટલે અહીંયા કંઈ જાદુ નથી થતો, પણ અહીંયા પ્રેશર આ 0.5 બાર છે. એટલે પ્રેશર ડ્રોપ થયું એના કારણે એનું સેચ્યુરેશન ટેમ્પરેચર ડ્રોપ થયું. સેચ્યુરેશન ટેમ્પરેચર ડ્રોપ થયું પણ સ્ટીમ તો એટલા જ ટેમ્પરેચર પર છે 100. એટલે શું કહેવાય કે 100 ડિગ્રીની જગ્યાએ હવે સેચ્યુરેશન ટેમ્પરેચર 81 થઈ ગયું. એટલે હવે તમારી સ્ટીમ 81 ડિગ્રી ડ્રાય સેચ્યુરેટેડ સ્ટીમ કહેવાય. અત્યારે આપણી સ્ટીમ તો 100 ડિગ્રી પર છે, એટલે ટેમ્પરરી આપણે શું કહીશું કે સ્ટીમ સુપર હીટેડ થઈ ગઈ. Okay, then what we have to do? We have to measure the pressure and temperature before throttling and after throttling, and we have to calculate the dryness fraction of the steam. આપણે આનો એક we will solve a numerical based on that, so easily you can understand that part. And if needed, you tell me, we will discuss on separate video on how to take the value from the steam table. Steam table का use कैसे करना है, that again we will discuss in a separate video if you wish. अभी उसका कंस्ट्रक्शन क्या है, तो यू कैन सी कंस्ट्रक्शन ऑफ द थ्रोटलिंग कैलोरीमीटर. This is a main steam inlet. Then here your second throttle device is there. This is a throttle device. Then your steam chamber will be there. Then your pressure gauge is there. One pressure gauge we have to keep here before throttling. One pressure gauge we have to keep here before throttling, after throttling. Then thermometer or temperature sensor again we have to place on both the place before throttling, after throttling. And exhaust outlet, that is all the steam that is condensed, that will be operated through this valve. When we will operate this valve, all condensate will come out. So same sketch is there, we will try to discuss in detail. So this is a main steam carrying pipeline where the pressure gauge is there, temperature is also measured, and now when the steam is available in this pipeline, here you can say your initial condition is 1, that is before throttling. Now this throttle valve is open. When we will keep this throttle valve open, the steam will start to flow through the throttle valve. So here is condition 2. So before throttle and after throttle we have to measure the pressure and temperature. Okay. So what we can understand is that when the steam will flow through the throttle valve, its pressure will drop temporarily, and when the pressure will drop, corresponding to that pressure, saturation temperature will drop also here. So what happens, temporarily this steam is converted into superheated steam. Now this superheated steam will follow this path and it is condensed and coming out through this throttling calorimeter. So here you can say one valve is there, and we can see what is the amount of liquid that is collected and what is the value of dryness fraction of the steam, that we can calculate when we know the pressure and temperature before throttling and pressure and temperature after throttling. So this is your throttle valve. Before that we have to measure the pressure and temperature of the steam, and after that again we have to measure the pressure and temperature. When this valve is open, all the condensate will come out, that indicate what is the total mass of the steam that is entered in the system, in this entire system. So what you can see, A small quantity of steam that is taken from the main steam line and that is passed through the calorimeter. What you will observe is the steam passed through the fine orifice or throttle valve. All of a sudden its pressure will drop. So the process occurs without any heat loss or heat gain. So there is no heat loss or heat gain. Enthalpy remains constant, that is H1 equals to H2. That is enthalpy before throttling, enthalpy after throttling remains same. And after throttling, the steam which was wet now becomes superheated, that will condense and that will be collected at bottom. So how to calculate X value? So in the next stage we are solving one or two numericals, so easily you can understand. So what we have to do, we have to measure the pressure after throttling, that is with suffix 2, before throttling, that is suffix 1. So we have to measure P2 T2 and P1 T1. Now as you know H1 equals to H2, so what you can see H1 equals to H2, that is equals to HF plus XHFG. This is for wet steam. This is a enthalpy calculation for wet steam, and we will get X value by simply doing what? H2 minus HF divided by HFG. So what is HF? Enthalpy of saturated liquid. This is enthalpy of evaporation, that is H1 equals to H2. So X is available, that is the dryness fraction, by HF, that is enthalpy of saturated water at initial pressure, HFG, that is latent heat of vaporization at initial temperature, that is before throttling. P1 we are talking, P1. P2 is after throttling. What is limitation of the calorimeter? A throttling calorimeter cannot be used if the steam is too wet, means if dryness fraction is less than 0.95, we cannot use it. And generally in a practice, along with the separating calorimeter, we have to place, after separating calorimeter, we have to put the throttling calorimeter, and that is called combined calorimeter, that is combined separating and throttling calorimeter. So alone separating calorimeter cannot be used, alone throttling calorimeter cannot be used. We have to combine these two and we have to use it. So let us solve one numerical so you can easily understand what is going on. You can see the pressure before throttling is 10 bar, after throttling is 1 bar, after throttling the temperature is 150. What is the dryness fraction? So what you can see here is your P2 is 1 bar. So corresponding to 1 bar, when you refer the steam table, this is a 1 bar line. So you can see this is a saturation temperature, because here it is mentioned this is saturation temperature. HF, that is enthalpy of saturated liquid. Enthalpy of saturated liquid. It is 417.4 or 5. Here saturated vapor enthalpy is given 2675, Hg value is given. Okay, so from that you can find out HFG, because HFG, what is that? That is Hg minus HF. Hg minus HF. So almost you can say 2675 minus 400, so it is almost 2275 or nearer to that value. So when you subtract 2675 minus 417, you will get the answer of HFG. Unit is kilojoule per kilogram. In the similar way, your initial pressure is 10 bar. So corresponding to 10 bar, the saturation temperature is 179. your HF value, that is 762, and Hg value, that is 2778. So if you want to find out HFG at 10 bar, it is almost, you can say, 2778 minus almost 762. So it is around 2010 or like that. That we have to use at later stage. So just we try to find out how to use the steam table. Okay, steam table में P2, that is after throttling and before throttling, pressure values are available. So just we have to refer the steam table, and corresponding to 1 bar and corresponding to 10 bar, we have to write all these value. Saturation temperature कितना है, enthalpy कितना है, if we want what is the internal energy, specific volume, entropy, all these things we can write directly from the steam table. जो यहाँ पे मेंशन है एच एफ, दैट इज़ 417, वो यहाँ पे अवेलेबल ही है, मैंने बताया. सेचुरेशन टेम्परेचर 100 लिखा है, वो ऑलमोस्ट यहाँ पे मेंशन ही है 99.62. एच एफ जी अवेलेबल नहीं है, लेकिन एच जी एंड एच एफ इज अवेलेबल. सो व्हेन यू गो फॉर एच जी माइनस एच एफ जी इज अवेलेबल. Now what is the formula to find out enthalpy of superheated steam? It is H2, that is Hg plus Cp of steam into saturation temperature and superheat temperature. So now what we have to do? Cp 2.1 kilojoule per kilogram Kelvin, and Hg, what I told, it is Hf plus Hg minus Hf, directly available from the steam table. This is 1 bar. So corresponding to 1 bar directly, I think that is available. 1 bar, what is the value of Hg? This is a 1 bar. So 1 bar Hg value, yes, 2675. So it is almost same. So this is 2675. It is same as what is mentioned in the steam table. Either you calculate or directly take from the steam table. So now you can calculate what is H2. H2, that is equals to Hg. So Hg value is available from here. This is the Hg value. Cp is 2.1. Saturation temperature and superheat temperatures. Superheat temperature is 150 given in the data, and corresponding to 1 bar, the here temperature is given corresponding to 1 bar. The saturation temperature is 100. So here your answer H2, that is 2779.5, very important unit, that is kilojoule per kilogram. Okay, kilojoule per kilogram. Now at 10 bar, we have to find out what is the value of HF and HFG. So what is one state before throttling? So HF plus XHFG, that is equals to H1, that is equals to H2. And we know how to find out dryness fraction H2. H2 is available. How to find out HF and HFG? This HF and HFG, you have to find out 8 P1 pressure from the steam table. So ये दो वैल्यूज जो स्टीम टेबल पे से आई है बिफोर थ्रोटलिंग, यही वैल्यू आपको यहाँ पे रखनी है. That is 762.6 and 2015.3. So dryness fraction is around 1. So we can say that the steam which is entering into the system is almost dry saturated steam. So by solving this numerical, we can understand working of throttling calorimeter, how to use the steam table, and how to solve the numerical using steam table. So in exam it may possible that steam table is given to you and you have to solve the numerical using steam table. स्टीम टेबल आपको आना ही चाहिए बिकॉज इट इज़ अ वेरी इंपॉर्टेंट एंड और अगर आप मैकेनिकल से हो या ऑटोमोबाइल से हो या इलेक्ट्रिकल इंजीनियरिंग से हो तो आपको तो पूरी ज़िंदगी वो चाहिए ही चाहिए. सो यू मस्ट नो हाउ टू सी द स्टीम टेबल. So this is about a throttling calorimeter. Do not forget to subscribe, like and share this video as well as channel. Again the channel name is AVM Tech Android. In the next video we'll discuss about combined separating and throttling calorimeter. Thank you very much.